Hello everybody! In this video we're going to see how we can use our regression analysis tool. Okay, so first things we want to do is open our hypothesis testing dashboard, go to the multiple regression because we use this both for single and multiple regression, and then just real quick, whatever we are wanting to predict, that goes in our blue column, and whatever we are using to make the predictions is going into our orange columns. Sometimes that means how the data is given to you, you need to switch the order that it's given. So let's read our scenario. So here it says, Megan is working with NASA to monitor a rover that has recently landed on Mars. Her job is to track the weather to determine when they should employ shields over the rover's sensors. Unfortunately, if she puts the shields up, they are unable to perform the mission experiments. But if she leaves them down during intense dust storms, the sensors will be permanently damaged. Her main concern is about the amount of particles in the atmosphere during the dust storms. Instead of sitting up all the time with her fingering hover over the shield now button, it would be too late anyways to protect the sensors due to the time it would take to send the signal. She thought it would be way better just to set up an algorithm to tell the rover when to shut down itself. Measuring the wind speed is one of the few sensors that is always safe to have running. As such, she wants to be able to predict the amount of particulates in the air based on the wind speed. So she starts taking measurements and wants to see if there's a relationship between the airspeed and the number of particulates in the air. She tests at the significance level of 6%. Okay. So let's kind of look down here and says, what type of data are we dealing with? Let's look at our data. So we have the particulates and the wind speed. We are trying to predict the amount of particulates in the air by the wind speed. So let's just go ahead and copy that, and we're going to go ahead and paste it in. We'll just do a paste special and text and click OK. This is numerical by numerical. We have two pieces of numerical data using one to predict the other. The predictor variable, or what we are using to make the prediction, is wind speed. And the response variable, or a dependent variable, is the particulates in the air. The population of interest is the atmospheric conditions near the rover. And the parameter of interest is the true mean number of particulates per cubic centimeter, or just particulates in the air. This next one that we're looking at is, do any of the requirements give you cause concern? If blank, leave blank. If no, perform an analysis if everything is okay. So if we look here, are we concerned about normality? No. Are we considered about centered about zero? No. Are we considered about linearity? No. We're not seeing any real patterns. We're seeing constant variance. That means no fanning. We're not seeing any main clusters. So we're just going to click none of these, and we're going to keep on going on. None of those are giving us cause for concerns. We have a nice little cloud going on. The method that we should be using for analysis is our regression. And because we're doing regression, we are going to be using the F statistic for testing our model. So the hypothesis that we set up is with our betas. Let's go ahead and grab our flow chart real quick. And let me just remind you that when we set up a regression analysis, let's go back to, give me just a second to pull it up. Okay, here we go for regression analysis. We can have multiple things that we want to predict, or we can have a single thing that we're wanting to predict. And right now we're just doing singles. So it is that our true slope, B1, is going to be equal to 0, which means that there's no relationship between the predictor and the response. And here we're going to say that it's not equal to 0, say that we actually have one. Okay, so the scatter plots here, we can get these, but I'm going to show you how we can figure these out. I'm not going to include these on the exam at all, but so that you can see these. Notice one's going to be like a positive slope, one's going to be like a negative slope. Just note that these are not going to be on the exam. But let's go ahead and take a look at how we can figure out, at least, do we have a positive slope or a negative slope? So let's scroll on over to our regression analysis. And what we want to go down here is look at our coefficients, and notice that we have a coefficient with a positive relationship. So that means that we're going to have a positive relationship between the wind speed and the number of particulates. So I'm pretty sure it's going to be this guy right here is our correct response. Yep, as a positive relationship. Now, I'm not going to put that in the exam, but I might ask you, do we have a positive relationship or a negative relationship? And so this one is definitely positive. Okay, identifier alpha. If we scroll back up top, we notice in here that it gave a significance level of 6%, so that is our alpha level of 6%. And now it's going to ask us for our B0 and our B1, or what is our sample intercept and our sample slope. And those are just underneath these coefficients. We can click them right here, and we get these coefficients of 3.2811 and 1.522. We get R squared, and R squared is up here. There's a couple of them. We see multiple R, but the one that we want is R squared. And this is simply the percentage of the variability in the data that is explained by the model. And so we can see that it's roughly 75%. And our F statistic is right here. And we get our F of 181. And we're looking at our p-value. And our p-value is essentially 0 for all intents and purposes. So we can just put in zeros to 4 decimal places. In here, in this yellow spot, we want to type in our alpha level 2 at 6%, and it will calculate out our confidence intervals for us as well. So the p-value here is going to be less than our alpha. So we put in a less than. And then our confidence interval, notice that we want the confidence interval of beta 1 of our slope here. Oops, we'll say pick a time. Back over here. And we see that we have our upper and our lower value here. So it's 1.3 to 1.7. There's our confidence interval. Our decision is going to be reject the null hypothesis. And we would say that, hey, we have collected sufficient evidence. And this is how we write out our evidence in APA format. F of 162 and then that 81. If you want to know why, it's just these degrees of freedoms. 162 and then our F statistic, we say that our p-value is less than 0.001 and an alpha level of 0.06 to reject the claim that there is no relationship between the wind speed and number of particulates in the air, and instead claim that there is a relationship between the two. Okay, our model was able to account for what percent of the variability? About 75% of the variability, which is a mediocre model. It's okay. We are 94% confident that for every 1 km/h increase in the wind speed, the true number of particulates per cubic centimeters increases somewhere between 1.3 and 1.7. So that's interpreting the slope of the confidence interval. Or the confidence interval of the slope, excuse me. Now, if we just wanted to say we're looking at the slope for here, we'd say that our model says that for every 1 km/h increase, that the that the particulates in the air increase by 1.5. Our confidence interval is just plus or minus from that. So that's how we go ahead and do our confidence interval using this regression analysis in our hypothesis testing dashboard. Good luck to you all.